How's it going, everybody? Mr. Rowan here to talk about angles. So, today we are doing Notes Unit 1, Day 5 types of angles, angle addition, and angle bisectors. So, ideally, angles are something that you've seen before in elementary school or middle school math. But here's a more formal geometry definition. An angle is two rays that share a common origination or initial point, which is called the vertex. So you'll notice we have ray HC as one side of our angle and HS as another side of our angle. So you've probably seen angles before, but maybe you haven't thought of them as a pair of rays. Um, so now you have. Now, when we're naming an angle, there are several different ways we can name it. The most common way is to use the 3 points that define an angle. And we always put the vertex in the middle, so we could do CHS or SHC. Either one is fine, but make sure that you do it in order so that the vertex is in the middle. You can also label it with the letter H, or sometimes you'll see just like a number, but that's not super common. The best practice to get into is to use the three letters CHS or SHC. Yes, the vertex H is the middle letter, and the name with three letters. Very important. Okay. Yeah. And you'll notice that when we have an angle, that we mark it with that little symbol there, the little arc. Okay, so an angle is measured in degrees using a tool called a protractor. Again, hopefully you've worked with these before, protractor. And we won't be doing a ton of direct angle measurement with a protractor, but in just a second I will show you how to use it. Okay, and a circle has 360 degrees. So think about a cool skateboarding trick. It's a 360 is all the way around. Why 360? Some people ask. It actually goes back to the ancient Babylonians who used 60 as their base for their number system. But that's not really important. Just a little piece of trivia for your next cocktail party when you're 21 in like 6 or 7 years or 5. Um, Anyhow, when we are measuring an angle, we want to line up our protractor so that one of the rays is at 0. And then we want to put that little point right in the middle. And then where our other ray lines up, then that is showing us how big the angle is. And in this case, since we're using the 0 on the inner ring, we're going to use the inner ring here. We're going to use 40. Yep, see? Right there, 40. Okay. So just take a second to get this down. Now, when it comes to classifying angles, there are 4 classifications that we use, and hopefully these should be familiar. Maybe you've seen them before, but maybe you've forgotten. So an acute angle, think of it as, oh, it's a cute little angle. It's little. It's an angle that is less than 90 degrees. Spelling is hard. Acute. Okay. And now we also have a right angle. Oh, yeah, let me just write down less than 90. So yeah, jot that down. And then oh, it's going away. We'll write it in more mathematical terms. X is less than 90 degrees. And now, when we are labeling a right angle, that is exactly 90 degrees, and we want to label it with that little box there. Now, if an angle is greater than 90 degrees, this is a little bit more efficient, then greater than 90 or less than 180, we call that an obtuse angle. Obtuse angle. And if x is exactly 180 degrees, then we call that a straight angle, also known as a line or opposite rays. But you will occasionally see straight angle used. And if x is more than 180 degrees, we don't really go into that so much in this course, at least not until we get to circles. But we will cross that bridge when we come to it. Alright, so next we're going to talk about adjacent angles and angle addition. So adjacent angles are two angles that share a ray. So in this case, SP would be the ray that they share. Just take a second here. So P is the interior of these two, of the big angle here, RST, and we would say that angle RSP, and remember to always do that little angle sign so we know what we're talking about, and angle PST are adjacent angles with the common ray. Now, how do we figure out what the common ray is? Well, it's the letters that they share. So in this case, P and S are the rays that they share. Okay. Changing the color here. With S, common ray, SP, there we go. And make sure that you put SP and not PS, because remember with rays, the order does matter, so you want S as your endpoint, and then extending outwards towards P forever. And the measure of RST, so the outer angles, is the sum of the measures of the adjacent angles. So this brings us back to part plus part equals whole. I told you it would come up a lot. I bet you didn't think it would be this soon. Ha ha ha. Tricked you. It is this soon. So we could write it like this. RST equals RSP plus angle PST. Can you see the yellow okay? Just squint your eyes and turn up the brightness on your monitor, or turn it down if you can't see it. Either way. Okay, let's move on to angle addition postulate. So if you've mastered the segment addition postulate, the angle addition postulate should be fairly easy for you. So let's just go ahead and start things off by talking about our angles. So angle TAR, and again we could call this RAT, but I don't think we want to talk about rats. We'd rather talk about tar. And car. Okay, we made a rhyme. That's good. Okay, so now we're gonna actually put some numbers in here. So for TAR, we happen to know that that is 40 degrees, but we don't know the measure of angle CAR. And by the way, I'm using the word informally. You wouldn't normally pronounce it. You would say measure of angle CAR. But anyway, we don't know the measure, so we'll call that X. And the measure of angle CAT, that whole thing is 120. So let's just add those up. 40 plus X equals 120, and some extremely difficult algebra. We cross out the 40s, and we have x equals 80. So that's part plus part equals whole. So we have 40 plus 80 equals 120. Sounds good. Okay, so we have measure of angle car equals 80 degrees. Feels good. All right, let's try an example. So why don't you pause the video and try this yourself, and once you come back, then we will walk through the steps together. Okay. So we have three angles here. We have RSP and PST, and RST is the big one. So if you have colors with you at the moment, I would recommend that you follow along, make your drawing colorful so that you can see why we do it. We do different colors so that you can see where one piece ends and the other begins. So 3x minus 5 over there. And then this whole big angle, yeah, we'll draw a super big arc. And that is 85 degrees. Okay. Now, getting back to our part plus part equals whole, we'll say one part, measure of angle RSP, plus purple, measure of angle PST, oops, forgot the angle sign, equals, in blue, measure of angle RST. See, small plus small equals the big part. So we're going to add up these expressions, 2x plus 10 plus 3x minus 5 equals 85, 85. Now, what do we do? All right, you can solve that on your own. Okay. All right. Now let's take a look at a new vocabulary term, which is angle bisector. So if you are solid with your segment bisector, then an angle bisector is the same thing. An angle bisector is a ray, segment, or a line that intersects the vertex of the angle and cuts the angle into two, what's that symbol? It's congruent to congruent parts, so that the adjacent angles will have equal measures. So, let's take a look at an example. So we have RQ bisects angle PRS. So let's just draw that. Okay. These are the same. Okay. We find the measure of angle PRQ. And now this is super important. It's not drawn to scale. If it were actually the case that PRQ was bigger than QRS as it appears on the diagram, we would not be able to solve this. But since it says it bisects it, we just know that the two angles are equal to each other. So we write ourselves an equation and do a little algebra. Why don't you pause the video and try to solve this? In the meantime, I will keep going.